Okay, so yeah, so I'll go with the question. So, let's say you have a service, a user profile service with billions of users, and each user is segmented into a category by using tags. So there are custom tags. There can be multiple tags. For example, one tag could be the age of the user, right? And um, each account might have a value associated with that particular tag. And similarly, there can be other tags. The question is to design a system that stores the tag and also lets you query and operate on the tags. For example, there could be a query which says, hey, you know what, give me all the users with age greater than 30 and who are male, something like that. And you should be able to efficiently query, list the users, and return it back to a particular set of services that request this info. This service should be for performant, and there shouldn't be, I mean, it should be flexible enough to add more and more tags. Did you understand the question?
Yeah, I think I understand the question. So now we got the user profiles, roughly a billion users profiles. And then basically we want to support, and on the profile, we want to support tagging, right? So first question I have is like is there max number of tags we need to support, or just could it be unlimited?
Yeah, for now, let's keep it unlimited.
Unlimited, right? Okay.
Yeah, this is because each team can come in and add their own tags. For example, let's say the user profile is profile service is used by a huge company like Microsoft. Each team could come in and add some tag to every user, and they can use those tags to query and operate on it.
Right. Okay. Cool. Could I assume that right now we already have a 1 billion user profiles, or I need to design the system also needs to create user profiles?
For now, let's assume that the user profiles itself, I mean, it doesn't matter. You can actually have both the user profile information and the tag information stored in the same DB or a different DB. It's totally up to you. I'll let you design the entire thing.
Okay, so now I think we need we support to create the user profiles, and then you know, add tags to user profiles, right? Okay, so that's the, and then we also need to be able to query user profiles, perhaps you know, by user some kind of ID, or by any tag or any tag combination.
Hey, would you help me with one thing? Could you enable dark mode in here? It just hurts my eye to actually see it right now.
This is too small. Okay, I see.
No, the dark mode. You can no. You can just click on the moon icon, which is on the top left. Yeah.
Top left.
No, below that.
Yeah.
Right. No, right. Yeah. Click on it.
Oh, okay. I see. I'm sorry. Yeah. Cool. So now this is correct, right? We want to query the user profile by any tags and um, or any tag combination, right? So now next question I have is what kind of combination we want to support? Is this just like we need support all and add operator or anything else?
Both and then or.
Both and or okay, cool. Okay, so I think I'm clear clear about the requirement, right? So we need the user profile service. Anybody can we can provide the API. Anybody can create a user profile, add tags to an existing user profile, and then they be able to query based on those tags, right? So, okay. Let's see. So we said that we're gonna have a 1 billion user profile, right? And what about the tags? I guess I try to figure out what's the right RPS, right? So how often we what's the number what's the RPS for tagging? I guess that's the question, right?
Yeah, you can say it's not that high, but it's still it needs to be flexible, so we cannot put in any restriction on it.
Okay, maybe
We can just assume that it is really small compared to the number of reads and queries.
right.
But I wouldn't put in any limit on that, because that would mean some team would get throttled, or the service will go down if some team starts immediately ingesting some tagging data. So I wouldn't essentially put any restriction on it. I'll let you come up with a decent enough number to accommodate things.
Cool. So we said okay. So basically right RPS is low, right? So but the read RPS could be like we want to support like maybe like 100K requests per second, something like that, right? That's too low.
Yeah, that's too high. How did you come up with that number?
I actually this is just a arbitrary number. I feel like if you talk about the user profile service that got 1 billion users, and you in a company you have other services, right? And I feel like a user profile service is very rudimentary service, basic service. The other service might, if you have lots of other services, it might just gonna query this service. So
that's great, but I would at least use some back of the envelope calculations to do to come with the 100K requests per second. Like, what are your assumptions behind coming up with this number, right? Because like, if it goes to 10 billion, would you still have 100K requests per second, or would you have a different number then?
Okay.
So,
yeah, that's
I'd
fair.
like to see your reasoning behind, even if it's in the ballpark, I'm okay, but I'd like to see a reasoning behind you come up with this number.
Yeah. So now let's say that's I think that's I should have done that, right? So now let's say because we have got a 1 billion user profiles, I assume every day we're gonna maybe 10%, maybe 20%, right? 20% of user profiles get tagged, right? So that's like 200 million, right? Is that right? billing.
Yeah, but why do you say only 20% of the user profiles get tagged?
Um, I mean, the typically why this typically, you don't get change to all 1 billion user profiles, right? So the going to be in a small percentage of the user profile gets changed, right? Every day.
So this is at at some point in time or total?
Let's say per day.
Okay, cool. Okay.
Yeah. Yeah, that's what yeah. And then maybe in 1 billion users profiles every day profiles. Let's say this might be in okay, 1 billion users profile, maybe I don't know, maybe like in 80% of users get access. That's the per day. So that's like an 800 million reads per day, right? So well, that's but maybe in each user profile gonna have a multiple access, right? So I don't know. I actually don't know how to estimate this. So
this one you probably need to go start with queries first, the number of queries that can come in, and based on the queries you can estimate the number of reads that would come in, because these are two separate things, right? First, a service would query to get the IDs of the users and then read the users themselves after that.
yeah, but then the query is like that depends on how much query gonna right. That the number of queries actually that might be independent of how number of user profiles, right? So so the number of queries queries. I don't know this if we can only give an arbitrary number, right? So
and you can come up with an arbitrary number for that.
Yeah. Let's say the 10 billion queries, right? Yeah, actually, that's a good approach, right? 10 billion queries. This is for reads per day, right? And then I want to figure out what's in the per second for the writes.
So, sorry to interrupt. So this is 10 billion queries. So do you think like there will be 10 billion times a query would be run per day? I mean, the query itself is not going to be, I mean, like it's going to be there, but I don't think it will be that frequent to query and filter things out. Maybe maybe 100 million is a decent 100 million, 10 to 100 million is a decent, even 10 to 100 million I think is high. It's probably a million queries per day. Million queries per day. Yeah.
Oh, okay. Okay, sure. And then 20 users gonna get, so this is wrong if that's the case, because we said that the writes are gonna be a lot more lower, right? I don't know. I'm not good at doing this, I guess. Yeah.
Okay.
Need some guidance here. Sorry.
Yeah. Yeah. For now, I think like writes is okay. Number of queries, 1 million queries per day is okay. But each query would actually return some number of users depending on how complex the query is. Assume that like the tags are decent, I mean like decently distributed, and they perform a decent job of kind of splitting people. Assume that each query can return um, a maximum of um, so there are a billion users. Assume that each query can return 100 million users max, which is an arbitrary number. For now, we can just live with it. 100 million users. Yeah.
Okay. I still have trouble with the number of writes. I want to figure out what's the write volume, right? So if 1 billion users, 20% gets tagged, maybe that's a typical case. That's high.
Yeah, but I mean, like, this is not just right, but there are also updates, right? Some tags may get updated after some time. For example, let's say the user, uh, the the user, we have a tag called teen, preteen, and things like that. When a user actually goes, I mean, like, moves from preteen to teen, then you have an update to the tag. So that also would constitute to writes. Um, so I think a 200 million is uh, um, a 20% is a decent number. 200 million is a decent number. Um,
200 million. But then what I confused here is why is the 1 million queries per day? Then I saw
yeah,
this is a lot more higher than writes in normal in this kind of system, right?
no. So there is read and then there is query, right? So read is you actually read an individual user profile. That's read. Whereas query is probably different here. Query, I meant is you actually submit a query saying, hey, I give me all the users who are age 13 and who are male, right? So that is the query or filter that I am
Yeah,
that
yeah.
specifying. Whereas the number of individual user profile items that you read, that is going to be significantly higher.
So this is like 200 million. I think that's like per day. It's like the per second probably is like the 2,000 requests per second for writes. Okay, that actually is not a whole lot. Okay, so I think obviously I'm not good at doing this.
Yeah, I think yeah. In the interest of time, maybe we can just like agree on a number and then go into it. For now, let's assume that um, the reach would be at least 100 times higher, which is 2000. Uh, so it's 2 million RPS then. Reading no, query is different from read. Yeah. So for now, let's say 1 million queries that are submitted to filter folks, and 2 million reads per second for reading the individual items. Yeah.
Okay.
Let's carry on with it. Let's not rat hole in this.
Cool. Awesome. Thank you for the why is a lot back. Okay, see. Okay, so I think the interesting times we're gonna move to the high level design. So at a high level, the here is like users or whatever apps, that's gonna cause or profile service, right? So the just because we need to support actually I want to break down the user profile service into the into two components. One is user profile write service, right? query service. Yeah, reason why I like to break down this, I think good idea to break this user profile service into two separate services, because rewrite, if you could have different performance requirement for reads and writes. For writes, maybe take a little bit of time, so like up to 1 second might be fine in some cases, but then in normal system, because you need to support a lot of reads, and a lot of times you want to read performances very little bit faster. So they have a different SLA between the reads and writes in most of the systems, and I feel like now we need to break the user profile service into the two separate components, or two separate services. And then let's see. So the next we need to figure out the storage, right? So the user, the clients, this is really clients, right? Gonna call the user profile write service, and then the write service is gonna just call, gonna make call to the database, right? This is our database. To write that data, right? And then write either user profile or tag data, right? So, but at the same time, because we need to support the 2 million reads per second for the query, and we need to query based on the tags. That means we need to create some kind of index. And now how to do that? I think it makes sense to have a queue whenever there's new tags, new user profile with tags being created. We can just put in a queue and have an index service to pick up the items from the queue, and then create an index, and then we want to persist on the index also, right? And then for the query service, it's gonna call, how to say, so indexing service is really creating index, right? And user profile, I think it can just go to the database, right? Can just query the database. So I think that at high level, this is the architecture, architecture, right? So there are things I was thinking about. Okay, I think that at a high level, this is the architecture that should do the work. So I think the critical part of these systems, it's how do we do the indexing, right? So I think in terms of writes, it's pretty straightforward. In the database, we're just gonna have profile ID, and then whatever profile data, right? Like the age, gender, user, the person's name, all those information. And then we could have, we could even store the text inside the inside this profile data, or we could have for ID with a list of tags, right? Like tag one, value one, something like that. Tag two, two. And then, of course, this information actually gonna also put in a queue, so we can trigger the indexing process. So I think this indexing process, this indexing service, is actually is a critical part of this entire system. So I like to go a little bit deeper and describe how we do the indexing. Right. Cool. So how do we do indexing? So this index, we just gonna create some kind of a reversed index, right? When we talk about the indexing, we talk about the document and what are the things we want to index. In this case, we want the index tag, and the document is just a profile, user profile, right? So the tag will be like this, right? Tag one will be linked to a list of user profile IDs, something like this, right? So so once we index service to pick up a user profile, and then it's gonna just look at all the tags for that profile and create this mapping. Keep updating this mapping. Of course, let's say you got two user profile with the two tags, the same tag one, right? So once you get that first user profile, you're gonna see tag one equals to user profile ID one, link to the user profile ID one inside that list. And then after you get in the user profile ID 2, and then you're gonna add user profile ID 2 into the list for that tag. So at a high level, this is just gonna be a reverse index, basically.
Okay, cool. So how would you store that reverse index? So I'm actually trying to go deep because we are already like 20-25 minutes into the interview. So let's talk about this one, right? So you are saying in the right database, you will have a profile ID and then profile data, which is okay. And then a profile ID and the list of tags, which is okay too. Are these, so what kind of a database is it? And are these, I mean, like key value store items, or are these in a relation database? What kind of a database is that?
Yeah, so I do not see a reason why we need to use relational database at all, because the user profile is pretty much it's independent, right? There's not much relationship between them for this particular service. So any NoSQL service database should work, whether it's a key value pair or columnar. NoSQL database should work, but in this case, I feel like we could just use the very simple, right, key value pair stores to do work. Basically, this is just key value pairs.
Totally makes sense. Okay.
Yeah.
Okay. Let me actually come back. So when the user profile write service actually has So is this two different requests, one to the database and one to the queue to add tags, or is it a single request?
Yeah, that's actually when I try to describe, I was thinking about actually actually I was thinking about maybe I want to do is like this. I wanna listen to the database changes and then put in a trigger, put in a queue. The benefit of doing this is like for the user profile write service, I do not need to worry about if one write succeeded, the other write to the queue failed, that those cases anymore. So I feel like this
totally makes sense. That is where I was getting to. Yeah, if you have two different requests, then there's a chance that one of the requests may fail and you end up in an inconsistent state. So this makes sense actually. Yeah, this is a better design. Okay, so now let's come to the indexing service, right? So when you say you have a reverse index of tag, so the list of values could be huge, right? Like in some cases it would be 100 million or even more. It could be 500 million at times, right? So in that case, how would you store this reverse index?
That's great. Yeah, that's a good question. So that's not actually the next things I want to talk about, how to partition this data, because this could be a lot of data, like you said, right? In terms of partition, we could there's two ways to partition the data, right? So one way is we partition by tag, but that just like you said, and if we got some popular tags, that inside this list could be 1 billion user profile IDs. And in the future, we might add, new more and more user profile IDs, and then it could run out of storage. That's one thing. So that's the drawback. Another problem with sharding by the tag is that when you make a query for like between two tags, I want the tag one to be this, and I want to find the user profiles that have a tag one and a tag two. Tag one maybe have 1 billion user IDs, and the tag two maybe also have a close to 1 billion user IDs, and then they might store in different machines because we sharding by tags. And we will have to transport that in the list of humongous user profile IDs to some centralized location, and then to do the intersection if we use the AND operator, right, for the query. If the query requires an AND operator, so that's the problems. Lots of network traffic. So with that, sharding by the tag name, it's not a good idea. So the much better approach is sharding by the user profile IDs. So basically, we're gonna have here we store the user profile ID one, right? And then want to your profile like the maybe write this way, like the 100K, right? User profile IDs, and here I gonna have another 100 profile IDs, right? And then inside this database, I gonna have tag one with a list of profile IDs only contains all these user profile IDs stored for this partition, right? So with that, for any partition, any shard, my reverse index, for any tag, the list is limited, right? Limited in size. If this, the number of user profiles IDs stored in the wall shard becomes so big, we can just add more shard evenly distributed the storage, I guess.
Okay,
right?
so there is the other problem where there could be too many tags, right? In which case, like even for 1K user profiles, you might end up exhausting the storage. So how would you handle that? So there are two cases, right? One is there are too many users in a particular shard. And the other is there are too many tags causing storage to go over. How would you handle that in that case?
Too many tags, too many tags. If that's the case, if that's the case, we can shard by, I guess, a combination of user profile ID plus tag name, right? Or whatever we could have a tag ID also for the name to save some space. So if we do that, this should work, right? So tag. I feel like either way is even this works. I mean, combination, but basically just combination for user tag ID and the user ID. We can deal with that case where
So,
tags.
okay, so would you explain how it would work then? So you have tag ID plus user profile ID, and what would be the value in that index? So do you mean you will shard by? So how would this work? I didn't understand quite yet.
Okay. Yeah. Let me think about that. Okay, I was thinking about this, I was thinking about this. So let's say I shard by this, right? By one of these, right? And in here, I know this sharding gonna contains a specific tag, and inside the user profile ID is only has the user profile side to it. So let's say, okay, let's give it an example, right? So let's say I got the tag 1, right? And user ID 1, right? These two combination is gonna side to a particular shard. Let's say it's for the sake of explaining how this works. So let's say the tag 1 and the user ID 1 are gonna side to here. And then inside the reverse index, which is gonna say in the tag 1, gonna have a user ID 1 if that the user profile ID 1 has tag 1 on it in it. If not, this list will be empty. Just for this example, right?
Okay.
I think that should work, but the other approach I could think about is that we can still shard by the profile ID, but inside each profile ID we have a sub shards, right? So for example, so this is for the user. So here is we got a 1K user profiles, and then inside the if we could, so this is actually the logical shard, right? We could treat it as a logical shard. Actually, we're gonna have a couple of machines, right? Separate machines. Sorry. So the separate machine was here, might just handle 10 tags, for example, right? And here is going to handle another 10 tags. And then, but all this shard gonna have have those wonky user profile IDs. That's really gonna have that, right? So now, if the tag from tag 0 to tag from tag 1 to tag 10, every wonky users, all the wonky users has those tags. That's those profile ID going to be in this shard. Basically, in the use the profile ID, it's like the parent shard or mesh, like the the main shard, but that's logical, right? Actual physical shard is also sharding by the tag ID within a set of user profile IDs. We could do that a little bit, but doing this, I think the drawback is a little bit complicated because you actually doing the sharding inside a shard, right? So the manage this probably going to have some operational cost. Whereas this is just wall flat, wall flat sharding key, just wall partition, one type of partition, the data. So it's might be a little bit easier to manage. With that, I think the next thing actually I feel like I haven't described is okay. I have all these shards, partitions stored in a tag, the reverse index. How can I make it?
Sorry, quick time check. So we are almost out of time, but because we took some time to come up with numbers initially, I'll actually give you 5 more minutes to finish things up.
Okay, cool, awesome. And then so query is going to have a query aggregator. Basically, this might become just the query survey, user profile query service. But I like to use aggregator. Basically, when user issue queries, gonna go to this aggregator, and the aggregator gonna talk to each shard to get the data. And then when the data returns, and query aggregator probably just gonna merge all the results from each partition, the data returned from each partition, and also maybe take the first top X result, top X user profiles are returned to the client. Whether top X, what's X, that could be not configurable, right? And also I want to say is like for some query it might become very hard. We could utilize some kind of caching to support. Just if we got some query is very popular, we could just put in a cache, and then if somebody queries again, we can just pull from the cache and return it. What else? So next things I want to touch upon is like the monitoring of this system. I think the critical part of this system, I think is this query part. We will have to monitor how fast the query and whether we need to scale up the query service or not, and maybe we need to add more shards. I think this reverse index, I don't think the storage might not be may not be the reason why we want to add more shards. More likely because we need to support lots of queries, and we just need to add more machines and more shards in order to deal with in order to support lots of read traffic. What else I want to say? In terms of failures, I think the query aggregator, all this can be in a stateless service, right? That's whether the client go to one particular query aggregator or not, it doesn't matter. This is stateless, so it can scale up, scale horizontally pretty easily. We just add more machines for an aggregator. For sharding, for index sharding, we could. I did not talk about the fault tolerance, right? So the index are that's pretty important data. So we want to at least create some replicas for each partition to just in case if the master shard had problem or down, we can just promote the replica to be to be responsible for that shard. Same as this database. This is the source of truth. This is raw data, original data. So we wanna have a replica and a shard by the profile ID. Each shard gonna have a replica to support and to be able to fault tolerant. And the queue, depends on how much how much data comes in, like the user profile updates. This thing we need to shard this thing also. And in terms of sharding key, I don't think we can just randomly shard the queue, and because in the indexing service pick up, it doesn't matter which profile ID to pick up the process. So this thing also we got multiple, right? To subscribe the queue to so that we can process all the user profile updates, right? User right profile service. This one is also I do not say the reason why we want to make this a stateful. So this is going to be a stateless service. So if traffic increase, we can just add more machines. And if one machine dies, then because if we have more machines, we probably not. Typically, we're going to have a load balancer before it, right? So if one machine dies, it doesn't matter too much. All the traffic is going to go to other machines, and because it's stateless, it's very easy to make it fault tolerant and scale up pretty nicely. And then for the query aggregator, probably we need to load balancer also, because this is also a bunch of machines running query aggregation, and the essentially doing the same thing on each machine. So stateless also, yeah.
Okay, cool.
I think that's it.
Cool, thank you. Yeah, I'll take some time to actually recollect and write feedback feedback. In the meantime, if somebody else has questions, feel free to discuss. I'll get back in like 10 minutes or so, and then we can go over the feedback.
Yep. Thank you.
Hi, anybody else has any questions? Feel free to use this time.
Yeah, anybody have any question, comments, feedbacks? Yeah, feedback is welcome, especially in things I could improve and yeah.
So I actually had a question about the sharding of the indices.
Yeah.
So you mentioned that you had you wanted to shard them by the user profile ID plus the tag ID. Could you just expand on how you plan to do that again? I might have just missed that part.
Yeah. So the user profile ID and the tag ID. So when we talk about the sharding, we're talking about the sharding key, right? That's just how the system decides where that data goes, right? Where that profile ID goes, or where that profile ID goes, where that tag ID goes. So let's say I got the tag 1 and the user ID 1, user profile ID 1. And then if this add up one of physical machines, this machines gonna only deal with only gonna deal with this tag 1 and the user ID 1. So we could have tag 2 and the user ID 2, right? Also, also map to that, or even the tag 1, user 2, tag 2, user 1, and could all these combinations could be added up in one shard, right? One shard. Yeah. And
sorry,
then
they could all be what?
So all these combination could be add up in this one physical machine.
Oh,
right?
I see.
Yeah, I see the problem maybe in the, I still have too many tags on these machines. Do I have that problem still?
Well, the way that I'm thinking, the way that you're explaining, the way I'm understanding, I guess, is that you're going to be storing the tag 1 user ID 1 in one database, tag 2 user ID 2 in another database. So those are going to be the keys.
Yeah.
Right?
Yeah.
And then the value would be, I guess, the profile ID or the user ID.
The value is still the data structure inside each shard is still going to be that in the tag column, a list of user profile IDs, right? If this tag 1 and the user, the profile IDs, the tag 1 and the user profile IDs in this data structure, let's do this, right? Let's say the user 1, user 2, right? If this machine is responsible for tag 1 and the user 1, as well as tag 1 and user 2, yeah, the reverse index, this reverse index will be stored in this shard.
One more quick question which I missed asking. So where is the value used here? Let's say the tag name is age, the value is 13. Where is the value used here?
Okay, I see what you mean. I think okay, so I think I missed that. So tag and value, right? I could just create the index, right? For the tag name and value combination at the reverse index k.
Yeah, so in that case, where would the value go?
The value would be part of the key, but there's a problem where I cannot support a range query, right?
Yeah, yeah, that's great. Okay, cool. That was what I was looking for. Yeah, range queries are hard to support in this anyway. So let's assume that like we don't have range queries in here.
Yeah, so if actually if we have a range query, we just need to use some kind of a database that can do the range query, like any database that supports like that's what's in the shorted string table, right? Which is the key is going to be ordered, and we're just going to scan that the case and find out all the values within the range. And once we find the key, we can get to the user profile IDs.
Thank you.
Yeah.
So just kind of to add on to this indexing part, I think doing that kind of searching or like range querying is might be expensive, as the other guy had mentioned. Is it possible to maybe just have the databases sharded by the tag ID, and then maybe have like multiple tag ID databases that are sharded by like the combination of tag ID and like some kind of a modulo operation on a user profile ID? That way, you don't really know which users are going to go there, but you know that based on the hashing algorithm, you have a deterministic way of one is that that database is going to hold just one tag, so it's easy to query against that tag. And then two, you have a list of users that fall into that modulo or whatever the hashing algorithm is, and you could kind of shard out the data that way, so one database doesn't get too big. Would that work?
Yeah, so I feel like that might be a problem, right? So a lot of times when a query comes in, it's not just query one tag, right? So so you could query two tags, right?
Mm-hmm.
And I need to get a result for the two tags, and if and then so let's say the query aggregator gonna get a tag one result for tag one from this shard, and then result for tag two from the second shard,
Mm-hmm.
and then that data has to transfer, and then do the logical operation, add operation needs to happen in the query aggregator. Whereas if I shard by the user profile IDs, I need to query all the shards, but the query aggregator is just doing the merging, right? That's one thing. That's one benefit of sharding by user profile ID. The second benefit of sharding by user profile ID is that, hey, if I have 100 shards, if one of shards has problem or respond very slow, I still have 99 shards to give me the data. So I can still return something back to the client very quickly, right? Missing data from one shard may not be a big deal in some cases.
Right. Okay. Maybe sorry, I guess if other people have questions, feel free to jump in. I feel like I'm asking a lot of questions here. I'll just wait maybe like 30 seconds before I ask my next question.
Okay, maybe I'll go next. So first a question. And before I begin, so a great job. Kudos for actually putting up a design which actually looks pretty decent, especially from scratch without using any major databases, which actually provide whatever you mentioned out of the box. So that's one. So coming to the question that I have, which kind of Z already pointed out that obviously the values are missing, which we already discussed earlier. But how is the sharding working? So what I understand that you're doing is basically using a local secondary index. And earlier you described something that was not going to work as a global secondary index. Am I right?
That's correct. That's basically that's I think that's the terminology, the local index. Yeah.
All right. So firstly, the tags, the question being here that the tags, as I saw in the requirements, that the tags could be unlimited. There are no limited attributes for a profile. It could be like you can actually keep adding tags as many as possible.
Yeah.
So given that is a scenario, each of these user profiles looks like a document rather than a column. Is that right? Because some of the tags or most of the tags for all of the profiles might be missing.
Could you repeat that again?
So since we are adding tags and they're unlimited, and the tags could be added to just specifically a very small section or subset of the profiles, they don't have any values at all, or the values are null for most of the other profiles. Is that right?
That could be the case, but our system does not provide somebody just update all the profiles with the same tag, right?
So let me rephrase. So let's suppose we already have like 100 tags for each of these profiles. Now I want to add a new tag. Let's call it the food preference, right? And I only have data for just one profile as of now. So do I actually add data for all the other profiles as null, or I just keep it as, I just keep it out of the database for all of these other profiles and just add the tag for the new profile that I have?
You just need to add in that case you just gonna do add that tag to one of a star.
Okay, so that means it is not a columnar database, it is more of a unstructured document database, right? Although it doesn't change your design, like just to clarify, it doesn't change your design at all. I'm just trying to clarify.
For me, this data, I don't care about what kind of NoSQL database. As long as it supports the key value pair, I'm good. If we want to support a range query, we need to have the NoSQL database support the range query. But that's the only. I don't care about. I really don't care about whether it's a document, type of database, or whatever. This data is a key value pair should be good enough if we do not need to support the range query.
Okay.
Yeah.
So since I have clarified that question, so like coming to the feedback or the critique, or maybe something that I'm actually probably missing out, something to discuss is that the pros and cons between, I do understand the pros and cons between the local secondary index and the global secondary index. Primarily being that you don't really have to worry about creating new shards when you're working with local secondary indexes. That is one, right? And since you're basically creating a reverse index for each of the tags that you're working with, it might actually put a strain. But the major con that I actually see is the scatter and the gather kind of queries. So imagine that, as I mentioned, like the food preference is only existing for a single profile, and we don't know which profile it is, right? Because in the reverse index for sure, because we don't really know which shard is that profile sitting in, because that's the only profile where that tag exists.
Yeah.
So technically, think about these cases where the number of tags or the number of profiles for a specific tag are quite low in number. I have to scatter and gather for all the shards, which is kind of wasteful. In case that actually is a way to go in this case, right? Versus let's suppose these are hot queries of sorts, right? versus the case where I do a global secondary index where I collect all the possible documents, right? Which documents by here, I mean profile IDs for tags. And obviously we are creating a reverse index on the tag as the as a table, and the values are basically or something values are something that you're basically sharding, I mean creating the index on, right? Like male and female would be two different values on which you're basically creating the index on. So, I mean, once you do that, you basically know, and since the main database and the reverse index database is completely independent, we don't really have to worry about where the tag. I mean, we don't have to like worry about the scatter and gather, because technically for each tag that I want to work with, I can just simply go to that table and just fetch whatever queries I want for.
Yeah, but like I said, right? So a lot of times you're not just querying one tag. So you
so when you're talking to KJ, I did listen to that point, and that actually is a great point. For that, like, have you considered? Let's suppose like you basically. So for the first query, obviously there is no a great solution for this. So let's suppose you basically have queries where you know the combination of tags that are being queried for, right? So you basically create a new table or new reverse index for each of these combinations as and when they're requested, depending on the threshold after which they're queried for. So for example, if I query the gender and the age at the same time, 10,000 times, right? Then it makes sense to actually create a reverse index query just for that, and so on.
Yeah. Well, I would think I would think that's what the caching does, right? So I mean, the caching is aggregated, already aggregated data, right? So but sharding by that at the storage level, I do not think we could do that, something like that, but I feel like the caching already taken care of that.
Okay.
Do you agree?
I'm not sure if the cache would actually take care of it. Maybe I'm wrong, but because the cache would store the data at the instance, right? At that instance of, whenever like the user client queries. So let's say like when I query right now, there's like 50 Johns that are 50 years old. And then like 10 minutes later, there may be like another John gets added, so now there's 51, but in the cache, there's only gonna be 50 in there, right? So the cache would also need to be updated, since this is a constantly, it's kind of like a live system where there could be constant updates to the system. So
I think in his defense, sorry to interrupt. In his defense, I think the system is not strongly consistent, and we're not aiming to be strongly consistent at all.
Gotcha. That makes sense.
That's fine, I guess.
Yeah. Right now, I should have described that, and I think that this kind of user profile query series, usually, hey, if you're missing data for the last 1 minute, what's the big deal, right? So on maybe it's a big deal. If big deal, then we have to design system differently now. Yeah.
Gotcha. Cool. Thanks for the clarification.
Yeah.
Yeah. So I actually have a decent amount of feedback to go into. So if nobody else has questions, I'll go into the feedback. Okay, I take that as nobody else has questions. So Heman, really good job at coming up with a decent design that actually works, as Serializer pointed out. I think like you did a fantastic job going into multiple components and also ensuring that it's at least a decent enough design that you can come up with in 45 minutes, right? So I think like this is the best design you could come up in 45 minutes if you haven't seen the system before. So that's really good. You really understood the question well, and you went over a lot of key concepts, right? Like you thought about sharding, how things would work at a massive scale. You also thought about caching. I mean, I don't know whether caching is a great strategy, but at least you have that mindset to think about that without me prompting you to actually go into caching and stuff. So that's a great thing. I so you voluntarily went into failure cases, and you also spoke about how you would avoid failures, like replication in that case, having standbys for indices and databases. So that's a really good thing. And you also answered most of my questions. You answered most of the questions that were posted by people who are listening in. So that's great job. And even though initially you missed the value, you were able to quickly recover from that and then suggest an alternative that would work. So really fantastic job at that. um, so coming to things that you can improve. So one thing that I noticed is you could have actually asked more questions about non-functional requirements and also how the system is supposed to work. I'll go into one specific thing, right? So one thing that I generally ask is if there is a system that actually handles both the read and write, I would ask about the latency part of it and the delay between write and read. For example, how long can you take before you essentially show the latest results, right? So that can help you zero in on multiple options. You can talk about multiple options in that case. So once the tags are written, how much time do you have before the updated values are reflected, right? So that can actually give you a lot of leverage into things. You can do offline jobs if the requirement is super low, right? Let's say somebody says, hey, you know what, I'm not worried too much about it. As long as you give it to me in like a day or so, I'm good. Then you can suggest an alternative approach. So always clarify those kind of things beforehand, before starting the design, so you have like multiple options and avenues to pick.
Mhm.
um, so other things are mostly logistics, where you can actually say, hey, you know what, this is how I would split the system, right? Like even though you actually split it into write and query, you can actually like write down APIs and what the API would look like. That would help you understand the system better. For example, one of the things that you could have gone into is paging, right? How paging would tie into things. We clearly mentioned that we are actually looking at an API, so you cannot obviously return 100 million the results. Like that's one of the numbers that I put in, right? 100 million results, right? So obviously you might have to calculate like whether you need paging, and if at all you need paging, like how the API would look like, and if you want to implement paging, how you can implement it, right? So those are things that you can at least discuss with the interviewer. So it would essentially say, hey, you know what, this guy is actually thinking about APIs as well while he is designing the system.
Yeah,
uh,
absolutely.
uh, and so this is just like one example, but I would say like think about how, like what the user needs, right? So you uh, when you're designing a system, the user actually comes first, and be it an API, be it a UI, you will have to think about from the user perspective on like how the usage of that API would be. Another general pattern that I noticed is um, you kind of like while you have a really good understanding and perspective of the system, it's always in an interview, it's always good to actually go into multiple choices for each of the decisions that you make, and the kind of reason about with the interviewer on why you are making that decision, right? For example, databases, right? You initially just mentioned database and some schema, right? But after I prompted, you actually went into whether you would use a relational database or a NoSQL and the reasons behind it. But some interviews may not uh, just like probe you into it. and they may expect you to actually like come up with a list of choices and then zero in on a choice based on some factors, right? For example, you can say, hey, these are the choices for a database, and these are the factors that I need to consider for this particular system. And for because of these reasons, I am actually choosing a NoSQL database, right? So if you do that beforehand, it'll be much clearer to the interviewer on why you are doing that. And you may also be able to kind of like detect some of the issues in the design beforehand if you actually reason about it with the interviewer. Um, the other thing is, this question actually could be done differently as well. There are like, obviously there is no correct answer for a system design question. One of the things that you could have done is during the non-functional requirement, kind of like probed me more and checked whether you can use existing systems that are already there, right? For example, Elasticsearch is something that works and that has features that could give you tags and indices and stuff like that. So could you just like spin up Elasticsearch instances and then like do something on top of it instead of designing something from scratch? While this may seem like a uh, given that you want to design things from scratch, we generally don't design everything from scratch at any point in time. So it's mostly using existing systems, and whether you can use the advantages of the existing system to build something that actually works. So that's something that you could discuss as well. Like maybe you can say, hey, you know what, Elasticsearch is an option. I haven't used this, but like I feel that this is a great option because it supports these features, right? So that's one discussion that you have, that you can have instead of diving deep into and implementing everything by yourself. Yeah, I also expected you to actually go into like global and local secondary indices and why you would use one over the other, because these are indices, right? So one more thing that I expected was kind of going into different types of indices. One thing that I felt could help here is bitmap index, because you have tag and value and then the list of users. Maybe you can create bitmap indices and then use that to perform and or queries. So that way it will be much simpler. Again, you for creating bitmap indices you need some time, and that's where clarifying the delay that you can have between write versus read will definitely help you. Let's say I say, hey, you know what, I'm worried only about the read latency. uh, the write to read delay can be like an hour, right? In that case, you can actually create bitmap indices and load bitmap indices in memory and do and or in a much more efficient way. And thinking about it, you can actually say, hey, you know what, tag one underscore value one, and for first 1,000 users, that's one data point that lives in one particular shard, and tag one underscore value two but for that 1,000 users can live in a different shard altogether, right? Because these are two different data points, and you can move these between different machines, because the only thing that you need is the query aggregator querying tag one underscore value one for the first 1,000 users. And if there is an AND query, tag two underscore value two for the same 1,000 users from a different system, and then do an and or operation in the query aggregator. So maybe think out of the box and then maybe come up with something that could essentially improve the performance of these queries. So that's something that I wanted to go into. Other than that, I think you did a decent job at most of these. Also talk about, hey, you know what, this system, uh, like I can, these are the success metrics for the system, right? Like what like apart from SLAs, you can also say, hey, you know what, this is what I will target as uptime for the system. This is what I will target as right to read latency, or ask the interviewer on like what he wants to target. And maybe some business metrics that could essentially that you would essentially come up with to measure the efficiency of your system at a later point in time. I'm not able to come up with anything right off the bat, but always having success metrics would at least um, let the interviewer know that you not only care about the beauty of the design, but also the business metrics, and you are driving your design based on the business metrics. Yeah, so that is pretty much what I had. I leave it up to other folks to actually.
Actually, can I ask you one question? Do you feel like this approach works? Actually not 100% sure, but I think it works. The sharding by the combination of user ID and the tag ID.
User ID and tag ID, I don't know whether it would work. If you have tag, I mean, I didn't think about that. So when you say you have user ID and tag ID, and then you use that as a combination, I don't think it would work. Because you need to then fetch all the users for that particular tag and value, which might be difficult.
Yeah, so now that is the second approach I described, like I shard by profile ID, and that and then I have a sub shard within that profile set of profile IDs, and that sub shard by tag ID. That should work.
Yeah, so yeah, in that case, then you will have to do a table scan, right, which we are planning to avoid. So in that case, if you shard by profile ID, you will essentially have to go to all the shards and then check whether each profile ID matches that tag and value, right? Then it's a table scan. Like you are, for every query, you are essentially reading all items, which is going to be super inefficient. Because the queries are based on tags and values, you want to essentially shard it the other way around, which is tag value, and then use the user profile IDs as the value in some form. It could be bitmap indice, it could be a hash of values, essentially depending on like how dense or how sparse the values are. You can use different approaches, but I don't think the other way around, like sharding based on user profile and using tags and values as sub partitions, I don't think that would work.
But I was concerned about the user list of user IDs. If we shard by the tag value pair, right? Then a list of user IDs could be a lot that could run out of storage, right?
Yeah, in that case, yeah, that's what I mentioned, right? Like you essentially don't have to put in all the users in the same shard. You could just say, hey, you know what, for the first 1,000 users, I will put it in this shard, or first million users, whatever the data point that you need, right? The first thing that I would do is tag one underscore value one, and then for the first 1,000 users who all have this tag one underscore value one, that would be in this hash set. And for the next 1,000 users or 10,000 users, I will have in a different hash set. You need an intelligent mechanism to say where all these tags underscore value ones are stored, and then you will have to send the queries to all the shards that store this, and then like kind of do some aggregation.
Okay, is that how the Elasticsearch does?
I need to look into it. I do not know how
Okay, cool. Awesome. That's the obviously I'll do research. Yeah. Got it. Thank you very much. Yeah. Anyway, I don't want to use too much times, but Anybody have any questions or?
Yeah. So do you have like anything, any feedback for me or other people who actually showed up?
No, I think you guys are pretty. I see this crowd is pretty advanced. I feel like all the questions, comments, obviously include. I feel like it's very valuable, very advanced. I have been to some other mock. This is there's a bunch of other people do this. I feel like those groups and the people are not advanced. I feel like this group is very advanced. So I'm glad did this and got all this feedback from all of you.
Thank you. Thank you, and good luck with your interviews.
Thank you, everybody. Bye bye.